Hello everyone, this is Group Zhibingye and Ding Su from Joint Corp Institute. Our topic of final project is dynamic voltage restore design. That is DVR. Here is our agenda. Our agenda mainly includes these parts: abstract, project objectives, introduction and background, methodology, results and discussions, and conclusion. As for methodology, it mainly includes three parts. First is basic principles of DVR. Second is parameter design. And at last, it is simulation and experiment. Here is our abstract. Our topic of this final project is dynamic voltage restore. Due to imbalances and fluctuation in power system, there is a great need in raising the power quality. So we will focus on principles of DVR and use MATLAB Simulink simulation to find out the result. And at last, we will do the feasibility analysis by the output we get. Here are our project objectives. There are mainly three parts. First, we need to determine the parameters of DVR. Second, we need to build dynamic voltage restore model in MATLAB Simulink. And at last, we use simulation to prove DVR can efficiently solve the voltage sag problem. Here is the introduction and the background part. After doing some researches, we found that wide use of the power electronic equipment and heavy loads lead to pollution in the power system. So there are great necessities of good power quality. Some electronic equipment is sensitive to power quality, especially in the important industrial production process. So any changes of voltage in the power system, like short-term interruption, pause, surge, drop, and so on, will cause huge economic losses. And the voltage sag is one problem of bad power quality. And as for the bad consequences of voltage sags, for users, voltage sags will make electronic devices not work in an optimal state. For the power system, the decrease of voltage will increase the power loss. Besides, if the system voltage is extremely low, the stability of the system voltage will be destroyed, and even voltage collapse will occur. And at last, you may wonder how DVR works. DVR is a series compensation device with energy storage device. It can eliminate the influence of the voltage harmonics, fluctuation, and flicks on load by compensating active power in addition to reactive power. So DVR can help solve voltage sag problem. Let's come to basic principles of DVR. When the detection system receives the signal of the grid voltage drop, it outputs the compensation voltage to ensure the load voltage is constant. Further, to ensure the normal operation of the equipment, DVR mainly consists of energy storage device, converter, filter, and transformer like figure 1. And figure 2 and 3 are circuit diagram of DVR and block diagram of DVR. Let's focus on control strategy of DVR. There are mainly two control strategies of DVR. The first one is feed-forward control. The second one is feedback control. As for feed-forward control, it mainly has the strength that its simple structure and good dynamic characteristics. And here is the block diagram in figure 4. And the second is feedback control. Its strength is it can avoid problems such as overshoot and deviation. And in figure 5 is the feedback control block diagram. In this design, we will mainly adopt the second method, the feedback control. Now let's welcome my teammate Ding Su.
Hello everyone, I'm Ding Su. The parameters of the main circuit have a great influence on the compensation performance. If these parameters are not appropriate, the compensation effect of the DVR will not be satisfactory. Therefore, we briefly introduce how the parameters of the main circuit are determined. The first part is the capacity of DVR. The capacity of the device should be calculated according to the compensation object. Assume the rated working current of the load is IL, the rated working voltage of the load is UL. Effective value of the compensation voltage is UDVR, and SL is the power of the load, alpha is the rate of voltage sag. Then we can get S is equal to UDVR product IL is also equal to the absolute value of alpha product UL and IL. It also can be written as the absolute value of alpha product SL. The second part is DC voltage of DVR. According to the structure of the DVR described earlier, we know that the DC power output by the energy storage device of the DVR is converted into AC power through the inverter, and finally the compensation voltage is obtained. The voltage on the DC side of the inverter will affect the compensation performance and effect. Generally, the phase voltage on the AC side of the inverter should be greater than the peak value of the compensation voltage. That is, UA is larger or equal to U compensation maximum. Assume U1 is voltage on the primary side of the transformer. U2 is the voltage on the secondary side of the transformer. We can get U2 is equal to N product U1, and U2 is equal to UA. That is, UA is larger or equal to N product U1 maximum. Finally, consider dynamic performance. We choose larger DC voltage, that is UD is equal to 3 product N product U1 maximum. The third part is LC filter. Generally, the filter circuit is a series inductor and a parallel capacitor. The filter should make the high-order harmonics have a great attenuation, and the fundamental wave voltage can pass without any attenuation. Ideally, the formula for selecting capacitor and inductors are these. Among them, omega 0 is the cutoff frequency, and ZL is the impedance. Combined with the previous knowledge, we get these outcomes. First, we use MATLAB Simulink to build the model of DVR. We obtain voltage waveforms of grid voltage, compensation voltage, and load voltage. Besides, we also use THD, that is total harmonic distortion, to analysis. According to the previous formulas, we calculate the parameters value. By the way, not all parameters use the value obtained from calculation, such as in the filter about capacitor and inductor. They should be adjusted by Simulink experiment to get the best effect. After determination of these parameters, we build the model. Fig 6 shows the model of dynamic voltage restorer, and Fig 7 is the model of supercapacitor. In this project, supercapacitor is the energy storage device in DVR. Now we can see here is supercapacitor. The next is experiment. We set total simulation time is 0.3 seconds. The voltage spike occurs from 0.1 second to 0.2 second, and we obtain the following results. In the same time, there are three waveforms and voltage. Three waveforms. They are grid voltage, compensation voltage, and load voltage. It's obvious that at 0.1 second, the grid voltage starts to sag. DVR will enter working state and compensate corresponding voltage there. Finally, the load voltage is abundant, and the final voltage and the load voltage is extremely close to the normal grid voltage. It has same voltage magnitude and smooth sinusoid waveform. Therefore, the sensitive load can operate normally. Though these figures with different voltage sag, all results are good. We also use THD as an indicator to analyze the final load voltage. From Fig 11, we can see the THD of normal load voltage is 0. And from Fig 12, we can see the THD of load voltage after compensation is only 1.17%. It's really small. According to the waveforms from Fig 8 to 10, the design DVR can cope with different voltage sags in the grid in a short time, and the compensation load voltage is close to normal load voltage. About THD analysis, it can be noticed that the THD of load voltage compensated by DVR is really small. The value is 1.17%. It shows a good waveform quality of the grid voltage after compensation of DVR. These results show that this DVR design can well compensate for voltage sag, and it meets objectives. This is our project timeline. We do these things. About the next step, we want to choose a more sensitive detection method and a more economic control strategy to improve the model of the DVR. Then we want to find the proper instrument to build a real DVR device. In the future, we also want to take some experiments in the lab. In this project, we learn much knowledge. The first is we know the essential process in the design of power electronic device. The second is we learn the basic principles and mathematics about DVR. The third is we practice the skills in MATLAB Simulink. I think this is really important. Finally, I want to do a conclusion. Voltage sag is the most common power quality problem in the world, and DVR is an effective method to solve this problem. In this project, we introduce the structure, principle, mathematical about the DVR, and we use MATLAB simulation software to build the model of DVR and build a corresponding environment to deal with the problem. After simulation and analyzing, we find that there are good waveforms and low THD of the grid voltage after compensation by DVR. They all shows that the DVR design can well compensate for voltage sag. Therefore, we know this DVR design is effective. And these are references in the project. Thanks for your listening.